Okay, so that's the first example I wanted to do. The second one is a little bit more complicated. I will leave the general formula for the binomial series expansion up here because we'll need it. And here we're dealing with something a little bit more complicated. It is 4 divided by 2x squared minus 7x plus 6. Okay. So in fact, there's 2 ways of approaching this problem, and I'll show you both. So let us think of this as 4 times. Now we're expanding in a binomial series. We're thinking of x should be a small number. Now, if x is 0, then we just have 4 divided by 6. So we're looking for x rather close to 0. So I'm going to change the order here because really it's the 6 that's the most important part of this thing here, if x is small, and 6 minus 7x plus 2x squared. Okay, all to the power of minus 1 here. Okay, so let us write that as 4 times. We need to make this part here look like that. So I need to pull out a factor of 6. So that is 6 to the power of minus 1 times 1 minus 7 over 6x plus 2 over 6x squared to the power of minus 1. So I've just taken a factor of 6 out of here, divide through by 6, you get 1 here, you get minus 7 over 6 here, you get plus 2 over 6 there with the x and the x squared. And we've got 1 over 6 coming out the front. And we're now in a position where we can start comparing these. This is a 1, that's a 1. And all of this stuff in here is going to be our x that we can write there. Okay, so this is equal to 4 over 6 times, okay, 1 plus n is minus 1, times x is all of this stuff here, minus 7 over 6x plus 1, that 2 over 6 is the same as 1 over 3, plus n times n minus 1 over 2, so it is minus 1 times minus 2 over 2 factorial, times all of this stuff squared, minus 7 over 6x plus 1 over 3x squared, all squared, plus dot dot dot. For this one, I'm only going to go to x squared, just because it's a bigger example. And to get to x cubed would involve more space than we have on the board. So let's try and deal with this. We've got here, at the front, we've got 2/3 times 1 plus. Now, how many x's do we have? We have, well, this term here has an x in it. This term here, well, it's got an x in it, but it's been squared. So there's going to be some x squared contributions from this term here, but there aren't any x's in it. So the only x that we've got is this one. So there's a minus 1 and a minus 7 over 6x, 7 over 6x. Now, how many x squareds do we have? Well, we've got minus 1/3 x squareds from there. And how many do we have from here? Well, the first term in this thing is 7 over 6, minus 7 over 6x all squared. So that will give us 49 over 36 x squareds. And the minus 1 minus 2 over 2 factorial is just 1. So that is plus 49 over 36 x squared. How many x cubes do we have, just out of interest? Well, we've got some x cubes coming from here, but for the cubic term here that I haven't written down, there would be an x cubed contribution as well. So if you wanted to work that out, you'd have to include that term there. Okay, and I can write this as 2/3 1 plus 7 over 6x, and then this number here, how many, if you take it over a common denominator, we've got, so it is 3 here, there's 36 there, so we need to multiply top and bottom by 12 to get this common denominator here. So it is 49 minus 12 over 36. 49 minus 12 is 37 divided by 36, x squared plus dot dot dot. And like I did in the first example, if you wanted to put x equal to 0.01 or some other number like that, you could put it in and put it in here and put it in here and check that in fact you get the same answer up to the point that we would expect. They won't be identical because I've only calculated out to x squared here, but they will be, you'll be able to pick out the agreement. So that is the first way of calculating this binomial series expansion. What I did is I just took this whole chunk of stuff here and called it x. Now, of course, we need to bear in mind what is the limits of this to be a valid series. Well, this stuff here has to be less than 1 in magnitude. So minus 7 over 6x plus 1/3 x squared should be less than 1 in absolute value, which is a little bit of an awkward thing to think about. So since we don't need it for the second approach, I won't expand this any further and try and work out which x's actually work in this. So there we've got one answer, and I'm going to do it as in a second way, and I'm going to show you that you get the same answer. So I'll write the first answer up here so that we've got a record of it. 2/3 1 plus 7 over 6x plus 37 over 36x squared plus dot dot dot. There's our first answer. Our second answer is going to say, well, expanding something like this is well, you can do it. We have just done it. But maybe can we factorize this and treat it as the product of two series? So that's something which is perhaps a little bit more of an unusual approach to this, but nonetheless, let's go and do it. So we can write this as, 4 here divided by, well, we're going to factorize this. And this is one where we can work out what the roots are by whatever means you like. This is a factorization, and just check that that's correct. 2x and x gives us 2x squared. The minus 3 and the minus 2 gives us plus 6. Minus 3x minus another 4x gives us minus 7x. So, and what I'm going to do now is treat each of these separately. So this I can write as 4 times minus 3 plus 2x to the power of minus 1 times minus 2 plus x to the power of minus 1. Okay, so I'm going to do a binomial expansion for each of these separately and then multiply them together. This is another approach to solving this, and it has the advantage that these things here are easier expansions to work out than the one that we did when we just lumped everything all together. So we need to do this. So this minus 2 plus x to the power of minus 1. Well, that minus 2 isn't a 1, so let's pull it out. So it's minus 2 to the power of minus 1 times 1. And then we have to divide by minus 2, so there's 1 minus x over 2 to the power of minus 1. So that is minus 2 to the minus 1 is just minus a half. And now we can do the binomial expansion of this thing. So there's 1 minus x over 2. So the first term is 1. Then we have n, which is minus 1, times x, which is minus x over 2. We've got n times n minus 1, so it's minus 1 times minus 2 divided by 2 factorial, minus x over 2 squared. And if we're only working to quadratic order, then that's as far as we need to go in that series. So this is minus a half times 1. We've got a minus 1 here and a minus x over 2, so there's plus x over 2. And then we've got a minus 1 times minus 2, which is 2 divided by 2 factorial, which is 1. The minus sign here vanishes because it's squared, so it's x squared over 4. Okay? So that's this part here. The other one we can do as well. So it is minus 3 plus 2x to the power of minus 1, which is, well, we need to bring out a minus 3 to the power of minus 1, and then to make the front look like 1, we're dividing by minus 3. So it is 1 minus 2/3 x to the power of minus 1. Sorry, that belongs there. So it is minus 1 over 3 times. We do the binomial expansion of this is 1 plus, and then it is n, which is minus 1, minus 2/3 x plus n times n minus 1 divided by 2 factorial times minus 2/3 x squared plus dot 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 dot, which is, so there's a minus 1/3 times 1. The minus 1s and the minus 2/3 give you plus 2/3 x plus the minus 1 minus 2 over 2 factorial gives you 1. The minus 2/3, the minus sign disappears because it's squared, so that's plus 4 over 9 x squared plus dot dot dot. Okay? Now when are these valid? We need, for this one to be valid, we need the absolute value of minus x over 2 should be less than 1. And for the other one to be valid, we need the absolute value of minus 2/3 x should be less than 1. Okay? So if we rearrange these a bit, so if the absolute value of a negative number is just a positive number, so the minus signs here disappear when you take absolute values, I can multiply both sides by 2. This gives us that the absolute value of x should be less than 2, and the other one here gives that the absolute value of x should be less than 3/2. And both of these conditions have to be satisfied. That means it is this condition that wins. Absolute value of x less than 3/2 is the one that it works for this series. It certainly works for this series as well, because 3/2 is less than 2. And that's what we're going to need because we want it to work for both series at the same time. All right, so we're now in a position where we can make progress with this fraction that we started with. This 4 over 2x squared minus 7x plus 6, we wrote it as 4 over 2x minus 3 times x minus 2, or 4 times minus 3 plus 2x to the minus 1 times minus 2 plus x to the minus 1. So let us write this as 4 times this minus 3 plus 2x, which is minus 3 plus 2x is here. So it is minus 1/3 times 1 plus 2/3 x plus 4/9 x squared plus dot 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 times, so that is the minus 3 plus 2x to the power of minus 1. And we now need the other one, which by chance is written down here, so that is minus 1/2 times 1 plus x over 2 plus x squared over 4 plus dot dot dot. Okay, so all I've done is I've separately worked out the expansion for minus 2 plus x to the power of minus 1, the expansion for minus 3 plus 2x to the power of minus 1, and we're going to write them down next to each other and multiply them out. So there we are, and we certainly need absolute value of x is less than 3/2 for both of these series to make sense. Okay, so let us take the constants first. We've got 4 and minus 1/3 and minus 1/2, so that the minuses cancel, and we've got 4 and 1/3, 4 times 1/3 times 1/2, which is 2/3, times, and now we've got these two series. So how many 1s do we have? Well, we've just got the 1 from multiplying that one with that one. How many x's do we have? Well, we've got 2/3 x's times 1, and 1 times 1/2 x. So we've got 2/3 x plus 1/2 x. how many x squareds do we have? Well, we've got 4/9 x squared times 1. We've got 2/3 x times 1/2 x. So that gives us 2/3 times 1/2 x squared. And we've got 1 times x squared over 4. So it's a quarter. And then we're going to have some cubic terms as well once we start multiplying the stuff that I've left out. Okay, but we're only going to x squared in this expansion. So this is equal to 2/3 times 1 plus, okay, we've got 2/3 here and 1/2. If you add those together, common denominator is 6. So that is 4/6 and 3/6 makes 7/6. And how many have we got here? We've got 4/9 plus 2/6. So it is 1/3 plus 1/4 x squared. And when you put that over common denominator, the common denominator, we've got a 9 and a 3 and a 4. So common denominator is 9 times 4, which is 36. And you multiply it out. You get 37/36 when you add them all up. And that, when we compare this with that, the two methods have given us the same answer. 2/3 here at the front, 1, 7/6, and the 37/36. And it's also given us a slightly clearer idea of what the limit of the range of validity of this expansion is. So in general, these binomial expansions are useful ways of well, amongst other things, approximating these kinds of functions when you have x being small.